Welcome back to a new session on bioenergy technologies. So already we have discussed different thermochemical and biological conversion methods of biomass. So in this we will discuss mainly biomass compaction or biomass. It's also known as biomass densification. So that is a physical conversion process. So here our biomass is what is
converted into a
biomass compaction? It is
more
a process
suitable
of
physical
increasing
form,
the density
which
of
is
biomass.
further we can use that.
So if you look, already we
in
have discussed
combustion,
different types of
gasification,
density,
etc.
the apparent density, etc. So the biomass density, when it is less, it will be very difficult for handling, transportation, etc. For example, if you consider sawdust, a biomass like sawdust or coir pith, etc., their density will be very less, and it is not suitable for certain applications. So if we have somehow increased the density of biomass, we have several advantages. One is it gives more uniform properties. So throughout it will give more uniform properties compared to its raw form. Then another important advantage is reduce the transportation cost. So how it will reduce the transportation cost? Because by densification we can increase the energy density. The energy density is the energy that can be liberated, unit density of that or unit volume of that biomass. So that will increase as this density increases, the energy density will also increase. So it will help to reduce the transportation cost. And another thing is it helps in simplified storage and handling. So if the biomass is of fine powder type, we will have a difficulty in storage as well as handling. It will absorb moisture and it may result in difficulty in combustion, gasification, etc. So in this, if you are converting our biomass into this biomass densification process, it simplifies the storage and the handling. That is another advantage. And another important thing is it gives uniform combustion. The biomass densification process will result in uniform combustion. But the only disadvantage is high cost associated with the densification process. So we have to consider the cost also. This densification process requires special press or machineries. So that is the one disadvantage associated with the densification process. Now what is the principle behind densification? So if you are using a biomass under high pressure, it will result in the mechanical interlocking, and it will increase the adhesion and cohesion force like van der Waals force, etc. So if you increase the pressure, slightly increase the pressure of biomass particles, these adhesion and cohesion force will increase, and it will form an intermolecular bond between the contact area. So this is a symbolic representation of that, a forming of bond in the two interparticles adjacent to it. And if you are at a pressure of 0.2 to around 5 megapascal, this space between the particle is reduced. And if you further increase the pressure at a certain stage, the walls of cellulose, so normally biomass wall will be made of cellulose, so that will get collapsed. And if we are using a binding agent, it will prevent the compressed material from coming back to this original form. So in a low pressure densification we require a binding agent, but if you are using very high pressure, this is not necessary, because that pressure itself will help to form the close interlocking of particles. And binders are normally used like molasses, tar, etc., and they will form a bond similar to solid bridge. So that is the principle behind densification process. So basically we are increasing pressure and some case we will be using some binding agent also. And what happen is the cell wall of the biomass will get collapsed, cellulose wall, and it will be in very close contact, and that will help to increase the density also. And we have two products. The biomass densification products are normally called a briquette if it has a diameter greater than 30 millimeters. That is, if the diameter is greater than around 3 centimeter and its length is very less, we call it as a briquette. But if the diameter is very small and the length is more, that is diameter is less than 3 centimeter and its length is more, we call it as a pellet. Even though these are not that much are dignified terms. So this is a typical example of briquette. So these are known as briquettes because its diameter is more and its length is relatively less. So diameter will be greater than 3 centimeter or more than that, and the pellets will be like this. It will have more length and its diameter will be less. And how will you classify this densification process? So based on pressure, we can classify this into three categories. That is high pressure compaction. So high pressure compaction use very high pressure in the range of 100 megapascal or more. So that much high pressure is used in high pressure compaction. And this high pressure compaction process releases sufficient lignin to agglomerate the briquette. So the lignin will be released by this high pressure, and that will help the binding of this densified product. So we does not require any binding agent in this high pressure compaction due to the release of this lignin. And medium pressure compaction will be carried out around 5 to 100 megapascal, that range. So here also we does not require any binders, but some case we require binders. If the pressure is around 5 megapascal only, we may require a binder depending upon the material, and heating also may be required in some case. So high pressure compaction, we does not require any heating or binders etc., because the pressure is that much high. It releases sufficient lignin to get that bonding happen. But medium pressure compaction, it will depend on biomass, material, pressure etc. And low pressure compaction, we are using a pressure less than 5 megapascal. So in this we are sure that we may require a binding agent. Low pressure compaction requires a binder. Then based on technology, that is based on what type of machines we are using for this pelletization or briquette formation, we have several classification. A few of them are important. One are piston press, screw press, roller press and pellet mill. So this is another classification. This is based on what machine we are used for this densified product, for obtaining densified product, and this is based on pressure only. So that is the difference between these two classifications. So these are the important four machines used in this biomass densification. So we will see one by one. So piston press, so it is a piston, basically a piston which reciprocates with the help of some hydraulic or pneumatic action, and the biomass will be fed through this funnel and it will go inside, and we will have a die here of required shape and dimensions, and the biomass will be pressed through this die and we will take it out. So that is the function, basic working of piston press. So in piston press, the piston punch the biomass material into a die with very high pressure, so that can be obtained from mechanically or hydraulically, whatever power. So basic action is a reciprocating action, and it is compressed and form a very dense briquette. So that is the working of piston press. So it is nothing complicated, it's a simple mechanism, but we will the main problem is here, the main element is a reciprocating one. So this is not a continuous operation. So the briquettes are formed not continuously, but it's a reciprocating operation. Then we have screw press. So screw press, we have a main working element is a screw, rotating screw. So here in screw press, a rotating screw takes the material from this feed port and it moves it through a heating. So heating mantle, it will pass through a die. So here we will have a die. This is a die. So it pressed against the die and helps to form the briquettes or pellets. So that is the working of screw press. So here we can see we have three distinct zones are there. One is a feeding zone where we are feeding the biomass. Then we have a transport zone. So the biomass is transported from this feeding zone to here by the movement of this screw. And we have an extrusion zone here with the die will be here and the extruded product will be taken out through this area. So that is the screw press. This is a continuous operation and we have three distinct zones here. And then another one is another advantage screw press produce high quality briquettes with a homogeneous structure and a good combustibility. So we are getting a high quality briquettes in screw press comparing to the piston press. And only less maintenance is required, that we know because it's a rotating element comparing to the reciprocating element of piston press. Here the maintenance will be very less. But the disadvantage is the wear of screw and the cost of these parts etc. will be comparatively high. So that is one disadvantage of screw press. Then another one is a roller press. So roller press basically consists of two rollers. So two rollers of same diameter, just like rolling. We are studying rolling, which is used for producing thin sheets in manufacturing process. So just like that, we have two rollers of same diameter rotating in opposite direction, like this. So we have two rollers rotating in opposite direction, and this biomass, powdered biomass, will be passed through this gap between the roller. So the roller will pressurize this biomass and convert it into a sheet form, and that sheet will be passed through a crusher, and after proper screening it will be taken out. So that is the roller press. So basically here biomass is forced through the gap between the two rollers and pressed into small pockets, forming the densified product. And here the distance between the rollers, that is this gap, that depends on many factors like type of biomass, what is the particle size of biomass, what is the moisture content, etc. And if you are using a binder, that gap will also change. So that is the different factors will play the key role in the gap, determining the gap between these rollers. And the main design parameter here is the roller diameter of the roller and the gap, the roller force and the die shape, etc. So that is the different parameters, design parameters that we can change for obtaining different types of compaction products. So this is another commonly used machinery for obtaining biomass compaction. And we will get a typical bulk density of around 450 to 550 kilogram per meter. The product will have this high density in this range after this biomass compaction. Then we have a pellet mill, another type of pellets are obtained. So it consists of a hard steel die with one or two rollers. So this is a typical pellet mill. So here you can see this is the unpelleted material, that is the biomass particles are fed inside this circle, and these are the rollers which is rotating, and these are the die. You can see on the circumference of this circle we have a number of dies, and a gap, small gap is provided between the die, and by the action of this roller the biomass will be forced through these small openings and it will be pressurized and we will get a pellets through the outside, and this using these knives we can cut our required length of pellets. So this we will get a large quantity of pellets in a very quick time. That is the advantage of this pellet mill. So here we are using a steel die. These are hard steel dies surrounded by one or two rollers, and by rotating the die and rollers, the feedstock is forced through the perforation to form densified pellets. So mostly here the die will be stationary and rollers will be rotating. So these are the dies. So mostly they will be stationary, and these one or two rollers will be rotating. And before passing into this circular ring, the biomass will mostly pass through a conditioner, because we have to add some steam in this pellet mill. We will be before passing the biomass particle inside, it should pass through some conditioner for application of steam, because the steam softens the biomass and gelatinizes and the starch content inside the biomass, and so that we will give more durable pellets. That is why the biomass particles before going inside is passed through a conditioner, where we are apply a small amount of steam for the more durability of these pellets. And knives, we can see one knife here, here also. So the cut of knives are provided to cut the pellet as they are extruded from the die. So this is another machinery used for formation of pellets. That is a pellet mill. And what are the typical binders are used? Already we know what is binder and how it is used, etc. So mainly two types of binding agents we are used. One is the organic binder and another one is inorganic binder. The organic binders normally used are bitumen, starch. So starch is a major binding agent used, molasses, coal tar, resin, etc. So these are some organic binders used in biomass densification, especially in low pressure machineries. We have to use any of these binders. And we have some inorganic binders also, like cement in some case, some special case, lime also can be used, clay some conditions, and sulfate liquor. So these are some inorganic binders used in some special case. So mostly we will be using starch, molasses, etc. In some case we will use clay, etc. So these are the binders used in biomass densification process. And if you compare this overall technology of all these four methods, this overall comparison of these four machines used, we have discussed, that is piston press, screw press, roller press, and pellet mill. So in this you can see here mainly here the piston press is the working is in strokes, that is in the reciprocating motion of the piston. It's not continuous, but the other three are this continuous motion is obtained. And if you look at the ton per hour, that is the production rate of this pelletization or briquetization, you can see the screw press is having very less, then piston press a little bit higher, but these two, that is the pellet mill and roller press, will have a high throughputs, that is high production rate. And density also, this pellet mill is having very good density comparing to other one. But maintenance, this piston press is having high maintenance due to the reciprocating movement. And if you analyze the combustion performance of the product obtained, the briquettes and pellets, this pellet mill and screw press is having very good properties, while the other two are not that much high. So this is the overall comparison which you have to look for different criterias for selecting of proper technology for biomass densification. So with this we are stopping. Thank you.